Hello everyone and welcome back to Clinical Cousins YouTube channel. Today we're going to be going over the basic EKG complex. Now, the electrical events of the heart are captured and measured by our lead cameras and recorded onto our EKG sheet. For our convenience, I've drawn a giant heart with all of the necessary electrical components for one atria and one ventricular contraction and repolarization, and I've also drawn an EKG paper with the positive and the negative areas shown here. So we're going to be using lead 2 because it is best oriented to capture the basic complex of the EKG. Now, we know that the left lower part of this lead is the positive camera, and the right upper portion of this lead is the negative portion of the lead. So we also know that the first cells to depolarize are the cells of the SA node, which are located in the posterior section of the right atria, and these SA nodal cells fire an impulse which is passed to each of the cells in the atria until eventually both of the atria become depolarized. Now, all of these small electrical vectors that the cells are generating can be summed up into one giant vector. This vector is basically just the average of all the electrical activity that is happening in both of the atria. This means that the majority of the electrical vectors in the atria point downward and leftward. Remember that because this is a depolarization vector, it passes positive potentials. Therefore, it generates a positive vector. What is the result? A positive vector is heading toward our positive lead or our positive camera. Remember the analogy about the pretty girl? If the pretty girl is walking towards you, you are going to become excited, and then you're going to write in your EKG journal that you are positive or you are very happy. Now, this first positive deflection is called the P wave, and we know that it represents atrial depolarization. Now, we know from our previous videos that the AV node works to temporarily halt or delay the electrical conduction from the atria to the ventricles. In fact, the AV node does this so well that it keeps the entire electrical vector a secret. It is actually so small that we cannot even see it on our EKG. Therefore, our EKG doesn't think that anything is happening. It doesn't think that there's a positive or a negative deflection, which means that we see on the EKG an isoelectric or flat line. Now, this is not flat line like your patient has died. It is an isoelectric line, which is basically means that there's no positive or negative deflections happening at this time. So after the P wave, this is called the PR segment, and we know that it represents AV nodal conduction. Now next, the AV node passes through the bundle of His. It gives that electrical potential to the bundle of His, and it gives it to the right and left bundle branches, but it just so happens that the left bundle branch is in the interventricular septum, and it is the first to depolarize and generate a vector. Now remember, because this is a depolarizing vector, it is a positive vector. Now the left bundle branch generates this positive vector that is oriented upwards and rightwards. Remember, this positive vector, this pretty lady, is heading away from our positive electrode. So how is he going to feel? He's going to feel sad. He's going to feel negative. This is why we have a negative deflection, which is called a Q wave. We now know that the Q wave is due to the interventricular septal depolarization away from our positive lead. Now, the next area to become excited is the major part of the ventricle. This is the majority of the ventricular muscle cells. This is the big daddy. This is the show. So it creates a positive depolarizing vector that travels towards the apex of the heart, which is downward and leftward. Because we know that this giant positive vector is traveling towards the positive electrode, it will create a major positive deflection. And this positive deflection is called the R wave. So we now know that the R wave is representative of major ventricular depolarization. Now, the last parts of the ventricles to depolarize, rather, are the bases of the ventricles. Now, these two bases have depolarizing positive vectors that travel upwards and rightwards, away from our positive lead camera. So we already know that this is going to create a negative deflection. Remember, the pretty lady is heading away from you. So what do you feel? You feel sad. And basically, we call this wave the S wave. We know that the S wave is representative of ventricular basal depolarization. As an aside, remember that the QRS complex is sharp. This is because it's using the fast Purkinje electrical system that is not present in the atria, which is why the atria are a little bit slower. They have these rounded tops. Now, after we have depolarized the bases of the ventricles, something interesting happens. We remember that all the ventricular cells are now they're depolarized. All of this is depolarized. And we remember that after initial depolarization, the calcium plateau occurs. Remember, we're not talking about EKG now, we're talking about the cardiac action potential. Now, the calcium plateau allows calcium into the cell, which basically stimulates our ventricles to contract, and it gives them enough time to squeeze out all that blood that they have inside them. So, while the ventricular cells are contracting, they are not being electrically stimulated. So, because there is no electrical activity at this moment, we say that there's another isoelectric line, which is called the ST segment. So the ST segment roughly correlates to the mechanical event of ventricular contraction. Remember, this is electrical, but it roughly correlates with the mechanical event of ventricular contraction. So, eventually, our ventricular cells have become repolarized. Now, because our cells are becoming more negative, remember, repolarization is negative. Because our cells are becoming more negative, a negative vector is created. The vector is heading from the apex of the heart towards the base of the heart. This happens to be a negative vector that is headed away from our positive camera. This generates a positive deflection that we call a T wave. Remember, negative, if a big mean girl is headed away from you, that's a good thing. We're going to call that a positive deflection, and that positive deflection is known as a T wave, which is representative of the repolarization or relaxation mechanically of the ventricles. Now, let's put this all together. We have atrial depolarization, which is a positive towards a positive. It's a good thing. That gives us our P wave. We have the isoelectric PR segment, which represents the conduction through the AV node. Remember, it's quiet, it's silent. Next, we have our interventricular depolarization, which gives us a positive to negative Q wave. Remember, something good is going away from us. That's a bad thing. It's a negative deflection, which we call the Q wave. Next, we have our major ventricular depolarization, which is a positive towards a positive, which gives us our R wave. And we have our basal ventricular depolarization, which gives us a positive towards a negative. A good thing is going away from us, which gives us our negative S wave deflection. And remember that the ST segment roughly correlates to the calcium plateau, which basically means that calcium is entering our ventricular myocytes, which leads to contraction, and it allows the ventricles to have that last bit of time to squeeze all of that blood out. So we say no electrical activity is happening, which is why we have this isoelectric ST segment. And remember, lastly, what we need to do is repolarize the ventricles so that we can do this all again. And we know from our previous videos that repolarization generates negative vectors. And this negative vector goes from the epicardium in the apex to the endocardium towards the base of the heart. So basically, we're sending a negative vector towards a negative. Remember, a negative plus a negative equals a positive. That is what gives us our T wave. So now, I've outlined this here. Take a second to pause the video, write this down. It'll really help you as it correlates to this. But I hope that you've learned something today. And as always, thank you for taking the time to learn with us. And please like and subscribe for more content.